Hello, my name is Fatih Furkan Erkeç. In this video, I'm going to do A/B testing, traffic shifting, and autoscaling in Amazon SageMaker lab environment. Introduction: in this lab, we will create an endpoint with multiple variants, splitting the traffic between them. Then, after testing and reviving the endpoint performance metric, you will shift the traffic to one variant and configure it to autoscale. Let's run this. Let's install and import the required models. That's gonna take a while, so let me pause the video here. Okay, it's completed. Now let's import matplotlib pyplot as plt. And let's import Boto3, SageMaker pandas, and Botocore. We will create an endpoint with multiple variants, two model trained to analyze customer feedback to classify the message into positive, neutral, and negative. Sentiments are saved in the following S3 bucket paths. These tar.js files contain the model artifacts which results from model training. Let's deploy an endpoint splitting the traffic between these two models 50-50 to perform A/B testing. Instead of creating PyTorch model object and calling model.deploy function, you will create endpoint configuration with multiple model variants. Here's the workflow you will follow to create an endpoint. Construct Docker image URI, then create SageMaker models, then create production variants, then create endpoint configuration and create endpoint. Construct Docker image URI. In this step, you will need to create the models in Amazon SageMaker, which retrieves the URI for the pre-built SageMaker. Docker image stored in Amazon Elastic Container Registry (ECR). Let's reconstruct the ECR URI, which you will pass into create model function later. See the instance type. For the purpose of this lab, we'll use relatively small instance. Please refer to this link for additional instance types. Exercise 1. Okay, we were at exercise 1. We will use PyTorch here. We got some error. Let's run it from here again. If there is any error, I'm not sure what's the error. Let me check it for real quick. Okay, I changed its uppercase letters to lowercase and it fixed. And create Amazon SageMaker models. Let's construct the model names. We will use following function to check if the model already exists in Amazon SageMaker. Exercise 2. Create an Amazon SageMaker model based on model A S3 URI data. Use smCreate model function, which requires the model name, Amazon SageMaker execution role, and a primary container description, primary container dictionary. The primary container includes S3 bucket location of the model artifacts, model data URL key, and image key. Okay, for this is that. Let's copy that. And okay, we don't take that like this, and for image reference underscore image underscore URI. Let's run it. Exercise 3. Use example in the cell above. Create Amazon SageMaker model based on model B S3 URI. Okay, let's do that. Model name and model name B, because we are creating for B. Execution role ARM, and that equals to 4. Let's run it. Okay. It's correct, but somehow we get an error. So let me copy that from here and just do that to B. Okay. Somehow I didn't see something, but probably I write it wrong. Set up Amazon SageMaker products production variants. A production variant is package SageMaker combined with the configuration related to how that model will be hosted. You'll construct the model in the section above. The hosting resources configuration includes information on how you want that model to be hosted, the number and type of instance, a pointer to the SageMaker package model, as well as a variant name and variant weight. A single SageMaker endpoint can actually include multiple production variants. Here's exercise 4. Create an Amazon SageMaker production variant for the SageMaker model with the model name A. Use production variants function passing model name A and instance type defined above. So we'll replace this none by model name A and with none instance type with inference underscore instance type. Exercise 5. Create an Amazon SageMaker production variant for SageMaker model name B. Okay, let's do that from basically take from here because it's same, just really small differences, and we'll change it to B, and that's it. Let's run this cell. Configure and create endpoint. You will use following functions to check if the endpoint configuration and endpoint itself already exist in Amazon SageMaker. Create and create the endpoint configuration by specifying the name and pointing to the two production variants that you just configured that tell SageMaker how you want to host those models. Construct the endpoint name, and we construct the endpoint name as AB like that. And here is exercise 6. We will replace none create endpoint with endpoint name and configuration defined above. So we will use model AB and point name, and in here and point config name. Let's run it. Revive the created endpoint configuration in the AWS console. Instructions, open the link, notes that you are in the section Amazon SageMaker endpoint configuration. Check the name of the endpoint configuration, its Amazon resource name, ARN, and production variants. Click on the production variants and check their container information, image, and model data location. So we get a warning here. Revive the created endpoint in the AWS console. You can see it in here, and productions, initial weights, it's working through. And revive the created endpoint in AWS console. Instructions, open the link, notice that you are in the section Amazon SageMaker endpoints. Check the name of the endpoint and IRN status. Below you can revive the monitoring metrics such as CPU memory and disk utilization. Further down you can see the endpoint configuration settings with its production variants. It's creating. We'll wait for the deploy. And let's run it and wait until it's deployed. So it's deployed. Now let's test the model. Test the model on few sample strings. Here we will pass the sample strings of the text endpoint in order to see the sentiment. You are given one example of each, however feel free to play around, change strings yourself. Create Amazon SageMaker predictor based on the deployed endpoint, and we have here exercise. We will change them, use predictor and endpoint name. Our endpoint name is model AB endpoint model endpoint. Sorry, the keyboard has just changed. So model AB endpoint underscore name, and here serializer will use JSON lines serializer, and here we'll use basically same as that, but not serializer, deserializer. Let's run it. Okay, we have now in here. We forgot to put this. Okay, predicted class 1 with probability 0.96, 0 with probability 0.57, almost 59, 58, and minus 1 with probability 0.76. Generate traffic and revive the endpoint performance metrics. Now we will generate traffic to analyze the endpoint performance. We will revive some of the metrics that Amazon SageMaker emits in CloudWatch: CPU utilization, latency, and invocations. A list of namespace and metrics can be found here in that link. And CloudWatch get metrics statics documentation can be found here in that link. But before that, let's create a function that will help to extract results from CloudWatch and plot them. And let's run that. Establish wide enough time bounds to show all the charts using same time frame. Set the list of the variance names to analyze variant A, variant B. Run some predictions to review the metrics for each variant. Okay, now let's query CloudWatch to get few metrics splits across variant. If you see metrics not yet available, please be patient, as metrics may take few minutes to appear in CloudWatch. Let's run these cells already and they will complete, and I'm gonna take a pause here. So we can see the plots in here. CPU utilization, variant A is blue, variant B is orange, and invocations in here. We can see the invocations by timestamp for variant A and variant B, and same colors. Invocations per instance, we can see it here, variant A and variant B. Mod latency, we can see here, variant B and variant A. Shift the traffic to the one variant and revive the endpoint for performance metrics. Generally, the winning model that would need to be chosen. The decision would be made based on endpoint performance metrics and some other business related evaluations, so you can say assume that the winning model is in the variant B and to shift all the traffic to it. Construct a list to updated endpoint traffic. No downtime occurs during this traffic shift activity. This may take a few minutes, please be patient. So I think it's finished, but we can wait while we are writing that exercise. Again, model underscore AB underscore endpoint underscore name. and in here updated underscore endpoint underscore config. Let's run this cell. Okay. While waiting for the updates or afterwards, you can revive the endpoint in AWS console. Open the link, notice that you are in the section endpoints, and we can see it's updating, and check the name of the endpoints and IRN status updating or in service. Below you can see the endpoint runtime settings with updated weights. So we can see real time it's updating. Let me stop the video a little minutes. I will continue when that finished. So it's now in service. Let's run that code. We have a warning, and let's run this cell and run some more predictions and view the metrics for each variant. I will wait for it to be execute. Okay, it's executed. Let's run these cells and see the metrics. We can see variant A and variant B CPU utilization chart here, and invocations here. Variant A is blue and variant B is orange. You can see invocations per instance and model latency here. Configure one variant to autoscale. Let's configure variant B to autoscale. You would not autoscale variant A since no traffic is being passed to it at this time. First, you need to define a scalable target. It's an AWS resource, and it's in this case you want to scale a SageMaker resource as indicated in the service namespace parameter. Then the resource ID is a SageMaker endpoint because autoscaling is used by other AWS resources. USCP parameters that will remain static for scaling SageMaker endpoints. Thus, the scalable dimension is a set value for SageMaker endpoint scaling. You also need to specify a few key parameters that control the min and max behavior for your machine learning instance. The min capacity indicates the minimum number of instances you plan to scale into. The max capacity is the maximum number of instances you want to scale up to. So in this case, you always want to have at least one instance running and a maximum of 2 during peak periods. Let's run it. We got a error. I don't know why. I think there's an error about roles. I don't know why I couldn't fix that. Maybe it's about the roles we are using on, but I don't know if we use that. Is it fixed or not? Maybe let's change it to execution role arm. And let's try it like that. I don't know, it's again giving error, so I will skip that part and let's run it. Check that parameters from the function above in the description of the scalable target. Autoscale describes scalable targets. We checked that parameters the function above here, the scalable targets. Probably it's gonna give an error again if you run that. Okay, it's running. Define and apply scaling policy using scaling policy function. The scaling policy provides additional information about the scaling behavior of our instance. Target tracking scaling refers to a specific autoscaling type supported by SageMaker that uses a scaling metric and a target value as the indicator to scale. In the scaling policy configuration, you have the predefined metric specification, which is the number of invocations on your instance, and the target value, which indicates the number of invocations per machine learning instance you want to allow before triggering your scaling policy. A scale out cooldown of 60 seconds means that after autoscaling successfully scales out, it starts to calculate the cooldown time. The scaling policy won't increase the desired capacity again until the cooldown period ends. The scale in cooldown setting of 300 seconds means that SageMaker will not attempt to start another cooldown phase within 300 seconds of when the last one completed. So let's run it. We again have an error. So I'm not sure how to fix that, so I will just continue. Generate traffic again and revive the endpoint in AWS console. And this will take approximately 1 to 2 minutes to run. So I'm gonna stop the video here. Running completed. Revive the autoscaling. Open the link. Notice that you are in the section Amazon SageMaker endpoints in here. And below you can see endpoint runtime settings with the instance counts. You can run predictions multiple times. Observe the increase of the instance count too. You can see here. And you can see the model errors, invocation per instance, model latency, invocation 5xx errors, 4xx errors, and the operational metrics in here. Let's run it. Yeah, as I showed. And upload the notebook into S3 bucket for grading purpose. You may need to click save button before upload. Let's save all. Yeah, it's saved, I think. Let's upload it. And now the video ends. Thank you for watching. Have a nice time. Have a nice day.